Okay, we're going to look at the cos rule, and again, we're going to prove it. So I think it falls out very, very quickly. And so what we're aiming for is this formula here, a squared equals b squared plus c squared minus 2bc cos a. And the way we're going to do it, we're going to look at this triangle first. And just as I've done every other time, I've dropped this height. That's why I like the way to do these, because we do it the same every single time. We drop the height and we allow everything to equal this. This is angle B, so this is side B. Angle A, so this is side A. This is angle C, so this is side C. So if we let this be X, this is going to be C minus X. Now, because this formula up here looks like Pythagoras, we're going to do everything in terms of Pythagoras. So let's look at this triangle first. In terms of Pythagoras, we get h squared, and this is basically the way we've done all of them. H squared is going to equal the hypotenuse squared minus the other short side squared, c minus x all squared. And then we're going to look at the other triangle that we formed. And in this triangle, we're going to look at exactly the same thing. What does h squared equal? H squared equals b squared minus x squared, b squared minus x squared. The only other thing that we've got is in our formula over here, we've got a cos A. So let's straight away put in what cos A is. Cos A is adjacent over hypotenuse. So cos A, as we get a special guest star appearance from the koala, cos A equals x over b. And we're going to write it out as x equals b cos A. Okay, special guest star, the koala, teaching the koala today. And let's label these. This is Formula 1, Formula 2, and Formula 3. And as we've done in every other proof, and this is why it's a nice way to do it, we've got a situation where we allow these two things to equal each other. We know that this equals h. We know that this equals h squared, so they equal each other. So we can write that a squared minus c minus x all squared. We know that equals the b squared minus x squared. And we'll just start simplifying things as much as possible. So a squared minus, let's expand this bracket, it's going to be c squared minus 2cx plus x squared. And that's going to equal b squared minus x squared. Now we're going to expand this bracket. There's a minus out the front, so it's going to change all those signs. So we're going to get a squared minus c squared plus 2cx minus x squared equals b squared minus x squared. And straight away that's nice, because you've got a minus x squared there and a minus x squared there, and they cancel out. And if we write it like the formula that we're aiming for, a squared equals b squared plus c squared minus 2bc cos a. If we write it like that, what we're going to get is a squared equals the b squared. This minus c squared, when we take it over, becomes plus c squared. This plus 2cx becomes minus 2cx. So we're getting fairly close. Now, we don't want this x though. So we go back to our third formula, and we know that x equals b cos a. So we're going to put this b cos a straight in here for x. So really it's just all these simultaneous equations. We've got three equations, and we're trying to simplify them using substitution, really. So a squared equals b squared plus c squared minus 2 times c times our x, which is b cos a, which is exactly what we were looking for. We could rewrite this as a squared equals b squared plus c squared minus 2bc cos a to make it perfect. But that's a nice simple proof, and all three proofs basically work the same way. We dropped this h and looked at everything in terms of that h. So it's something that I think we could see again at some point. And And I think it's a proof. They're proofs that people can do and get out. So let's look at how it works. And this is not an easy example. It's not the easiest example, but it's something that you should be able to do. So maybe if you stop the video, have a go at it, and then work through the answers with me might be the nice way to do it. So this is the angle we're trying to find. So this is the side. This is angle A. So as long as we get that is A, we should be right. So 11 squared equals 10 squared plus 13 squared minus 2 times 10 times 13 times cos theta, what we're trying to find. And we'll just try to simplify as much as possible. This is 121 equals 100 plus 169 minus 10 13 is 130, so it's minus 260 cos theta. This is what we're trying to find, and it's a negative, so let's take that over and make it a positive straight away. 260 cos theta equals 100 plus 169 minus the 121. So 260 cos theta equals, that's 269, minus 100 is 169, minus 20 is 149, minus 1 is 48. And we really want to know what cos theta is. We actually want to know what theta is, but we need to get to cos theta. So we're dividing by 260, so it's 48 over 260. And then it's just a matter of doing that on the calculator. Second function, cos, make sure we're in degrees or radians, whatever we want the answer to be in. 48 divided by 260, and that theta equals 79.36 degrees. Okay, and that's a nice simple one. This is a little bit harder. This one, again, it's not a straightforward substituting the formula and find A. What we notice here is that the 14 would be our A squared. We know cos A, and we're finding one of these. So we're finding like B. So maybe have a go at that. See how you go. You'll probably have to solve a quadratic. Stop the video and then start it up again, and we'll go through it with me as I go through it. So substituting everything in, this is our A. So we get 14 squared equals 10 squared plus x squared. So that's what we're trying to find. Minus 2 times 10 times x times cos 60. Again, let's do as much as we can first and then start simplifying it. Now 14 squared equals 196. So we get 196 equals 100 plus x squared minus 2 times 10 is 20, and cos 60 is a half. So this is just going to be 10x. And that's where we're going to get our quadratic from. So we're going to get x squared. Now, whenever we're solving a quadratic, I notice it's a quadratic, so we don't take x's to one side and everything else to the other. When we're solving quadratics, we take everything over to one side, so we get x squared minus 10x, and it's going to be minus 96 equals 0. Now, solving that's quite difficult. Now, I've already done it. We're looking for numbers that times together to give 96 and add together to give 10. The way I sometimes look at it is that's going to be 2 times 48, which doesn't give us I always start with the product. 2 times 48, 4 times 24, 8 times 12. I'm getting closer to 10, but 8 times 12 doesn't cut it. But if I double this side to get 16 and half that side to get 6, I know it equals 96. So all I've done there is doubled this side and halved this side until I get a difference of 10. So I know this is going to be x minus 16, x plus 6 equals 0. Therefore, x equals 16 or minus 6. So sometimes with these, we get a quadratic at the end. We don't this is